This elegant building has had its ups and downs. Over the years, it has served well as an art gallery, a warehouse for telephone books, a garage for army trucks and jeeps, shelter for 18 indoor tennis courts, and as the fire station for San Francisco Engine Company No. 6. But now, after this long history of civic service, the Palace of Fine Arts is the permanent home of a science museum unlike any other in the world. The Exploratorium. Today, like most days, the museum's younger staff members have arrived early, before the place opens.
Hey, I'm not bad, huh? Let's try this again now. Let's see how we do this. Good shot.
They're called explainers, and it's their job to demonstrate the museum's exhibits for the public.
Tell us, why is the Frisbee work?
It's spinning, so it's got an inertia, right? Where it doesn't want to, tilt back and forth. And it also has the airfoil effect of the air going over the top, just like an airplane wing.
It has something to do with air pressure, right? Low pressure on the bottom, high pressure going on the top, which creates lift, something of that nature?
I'm not sure. I think it has something to do with the shape and how the air flows under it.
Oh yeah, the little curved edges, like the air lifts it.
Makes
rotational inertia, and on the top it's just airfoil.
And if you just drop the Frisbee without it spinning, it'll twiggle and fall like a leaf.
Munchkins, you see, that hold up the Frisbee as we throw it and travel along with it. Right there.
You know when you turn a bucket?
Mm-hmm.
You know how it moves across the floor if you turn it like that? Well, a Frisbee turns around all the time,
Oh, so you think it's the spinning of the Frisbee that has something to do with it?
And the airlift.
Well, let's see. Oh, well, it definitely has something to do with aerodynamics, and it's also have something to do with possibly airlift. So maybe I don't really know.
I quit. Frank's gonna kill me if I ruin any of the exhibits. Catch it! Watch it!
About 5 minutes.
5 minutes. Back part's on. Whose job is it? Hello?
But out in a vacuum, there's nothing to absorb and re-emit the radiation. So light, in some sense, it propagates itself. There's an electrical field, and that creates a magnetic field, and that collapses and creates an electric field.
I'm bored of cow's eye, not laser. I'm tired of laser.
You could have my cow's eye if you wanted, because I got to be working at the door.
Give me drawing board.
The Exploratorium is run by an unlikely collection of scientists, artists, students, and teachers, and everyone here is a little of each.
Light. And time equals 0. So the light that left the star and the light that arrives in your eye, relative to light, that's an instantaneous event.
Darlene Librero started work as an explainer several years ago, while she was still in high school.
Shelley, take a walk on that side of the museum and make sure it's on, and then take a walk upstairs and make sure all those exhibits are on.
Now she's the supervisor in charge of 28 explainers, who in turn oversee nearly 500 exhibits. The cloud chamber, resonant pendulum, cow's eye dissection, shoe tester, seismograph, aeolian harp, angles, angels, avalanche, neutron radiographs, catenary.
I will, please.
I always had your best drawing work. I always...
We don't have cow's eyes yet.
Yes, we do. They just showed up. They're nice, boy. They're fresh. They got nice brown irises.
Look, you had it for the last 2 weeks.
You'll pay.
Oh boy, here. Okay. But on one condition. I get it at 10:30 exactly.
Okay. 10:30. 45
Exactly.
minutes.
Okay.
Sucker!
black sand, brine shrimp, cellophane fish, compound interest, computers, cosmic rays, differential, electromagnetic spectrum, garden of anodes, pretty things, momentum machine, optical scattering, random dot stereo.
Hi, I'd like to welcome you all to the Exploratorium. And what makes this place special is that you become part of each of the exhibits. We want you to touch everything, play, experiment, explore. It's all hands-on. You can't break anything, nothing will hurt you, and basically there are no rules inside. Have a real good time. Don't crowd the doors. Just come in this one, and we're open.
The first time you've been here?
No, about the 30th, I guess.
30th time you've been here?
I imagine.
Well, that's where all the colours merge together.
The Exploratorium is like a scientific public park where playful tinkering and hard science go hand in hand.
Hey, that's perfect.
Behind this apparent chaos lies a disciplined scientific order, a complex system of exhibits grouped according to natural phenomena.
This thing has its natural frequency, and if you don't pull its natural frequency, you can pull all day long and this thing would never move.
That's bad. Check that out. What is it? Well, if the air pressure goes away from it, it'll go up. If it goes near, it'll go down.
Dr. Frank Oppenheimer has spent most of his life as a physicist and as a cattle rancher, high school teacher, and university professor. He is the founder and director of what some consider the best science museum in the world.
Near the vortex somewhere, it'd be fun to have it.
Well, it could be near the momentum machine, or better, it should be really near the rotating plants. I think this wire is broken. I'll put it in here and push the button. There it goes, back and forth and back and forth. The whole point of the Exploratorium is to make it possible for people to feel they can understand the world around them. I think a lot of people have given up with that understanding, and if they give it up with the physical world around them, they give it up with the social and political world as well. If you stopped trying to understand things and things kept changing, I think we'd all be sunk. That's right. Now push the button. That's it. One woman said after she went home from the Exploratorium, she wired the plug on a lamp cord. Now, there's nothing in the museum that teaches you how to wire a plug on a lamp cord, but somehow it gave her the confidence that she could do something like that.
So it's a different kind of exponential growth on the bicycle, possibly.
Wave propagation, the waveguide, waveform, wave machine, the longitudinal wave. Nearly all the exhibits are built here in the Exploratorium shop. The shop itself is open to view. Just another exhibit.
We had a graphic artist who wanted to put a big plastic wall up, but he didn't know that part of the shop was the way a shop smells when you burn the wood in the saw or smell the oil from the lathe.
Someone's always working on a new idea.
It's so nice and direct.
Rob Semper and Dave Fleming know that a strip of iron attached to a magnet will quickly lose its magnetic properties and detach when heated to 1400 degrees Fahrenheit. This temperature is called the curie point of the metal.
Of course, the problem is the magnet gets pretty hot this way, too.
But understanding the phenomenon is only the first step toward building an exhibit.
Just difficult to make with a propane torch. Also the fact that, we haven't figured out how to have flame on the floor.
Hold your right hand still and move your left hand. Everybody's not moving.
How many tubes are in there?
Just two.
Many exhibits are disarmingly simple, and most are understandable at a number of levels.
Over there, no?
Get out.
Where'd he go? I think that's wild. That's beautiful.
A simple sheet of mirrored glass is partly a carnival sideshow, partly an investigation of symmetry, visual perception, incidence, reflectance, real images, and reflected images.
Mirrors I find very confusing to this day, and I think it takes a lot of getting used to. And you start when you're little and learn about mirrors, and it's a lifelong process, really. That's why it's so surprising. It's so different from what you expect. Any mirror is a magical sort of thing. And we pay a great deal of attention to the role of aesthetics, the feel of it, the structure of it, the building up of suspense and the relief of tension. But these are things that have to go hand in hand with much more didactic forms of teaching.
Frank himself has built many of the exhibits. He's from the old school, trained as a physicist in the great laboratories of the 1930s, when most scientists built their own apparatus. He's made exhibits on heat and temperature, electricity, vision, hearing, and a host of other phenomena. But today his thoughts are on resonance, the marvel of sympathetic vibration. Atoms, bells, musical instruments, bridges, pendulums, anything set to ringing, swinging, or vibrating by forces around it.
I'll put bearings in here eventually, but I want to try it out first without bearings.
Frank wants to demonstrate modes of resonance with a simple, large-scale exhibit in which one pendulum will set another into motion.
So now if I take one of these,
Won't be damned.
see how long it goes. It stops. That's pretty nice. I suppose there's a lot of practical fruits to understanding, but it's like sex. There are a lot of practical fruits to sex, but nobody would say that's why you do it normally. So I think there are other reasons for understanding, which have to do with the built-in urge to do that, to really want to see why things are going on.
The idea for a Curie Point exhibit has now progressed to prototype stage.
Yeah, God, it's hot. Yeah.
Rob and Dave have cannibalized the shop's arc welder to see if its electric current will heat a narrow strip of steel beyond the Curie point.
It's a great way to ruin magnets. That was the problem with the battery.
There it goes. Okay, turn it off again. Perfect exhibit. Good. So it's got a good time scale to it. This is magnets on fire.
If the magnet's on a pendulum, you just heat it up and the thing would swing free like a pendulum again. You cool it down and it would suck right back over to the edge.
You still would need, you'd have to have a really strong small magnet then.
That's why I was saying one of Gibson's rare.
Nature is full of surprises.
But it's a good idea to have the variac on the...
If one sits at a drawing board and tries to do an exhibit, one could do a very good job, but then the person who's building it isn't allowed to react to the surprises that come up in the process of building it.
Would stainless have less oxide capabilities?
And the result is that things come up which make the exhibit more interesting and more beautiful or more agreeable to operate.
It'd probably knock a big hole in the metal after every time it opened up.
It's going to arc too much.
You could just put an LED and a photodetector.
It won't arc it.
Well, you can have a pendulum, you can make the pendulum a solid rod and actually go back to this technique again.
We lost it. There went through.
Right. Oh yeah.
Great. Well, that solves that problem.
That's how long it lasts.
Yeah, we have to replace it every 10 minutes.
You see that one structure on the hub of the wheel as it goes around? You can see how the linkages work on this. The piston's going back and forth. That makes the tie rods go, and they're connected to the cam over there.
The museum, it has this social aspect. It's like taking a walk through the woods. If you're all by yourself, you really don't notice a lot, but if there's somebody there, somebody will point out a flower or an animal or a special tree. So a lot of the noticing takes place because people stimulate each other.
Now I just see.
Now I just see you. Wait a minute, this is weird.
But with the magnet, you can move that 400 pounds.
I got it to go further now, look.
That's a freak of nature.
Look. It's just like
no,
taking...
you try it. You try it.
It's just like taking the dirt from what
yeah,
Many exhibits actually require two people working together, like the pitch changer or delayed speech.
Hello? Does that sound like my voice?
Yes, it does. Shut up, Ronnie.
The prototype for a new language exhibit is being tested on the floor. Noise from a duck call is routed through a vacuum cleaner hose into one of 5 resonant air chambers. Each chamber shapes the noise into a different vowel sound, A, E, I, O, or U. It needs work. Richard Green is beginning an improved version of vocal vowels. The trickiest job is forming new air chambers which mirror the shape of a person's throat and mouth.
Well, this represents the mouth end of the vocal tract, and for O, the lips and the front of the mouth are closer together than they are for aw. So it's more constricted down here than this one is.
It's better.
How is it better? How's it different?
It's more like O and less like aw. See this one?
The first thing you ever see about an exhibit here is a full-scale prototype where the phenomenon is really out there in its full glory. So there isn't anything drawn out on paper first. And that means that there's a heavy reliance on the machine shop and there's a heavy reliance on tinkering around with actual equipment until you get to a point where you can see the exhibit. And then that prototype gets played with a lot of people, both visitors and also staff, actually staff at first and then visitors. And that really affects the way it gets built. And somehow that's the experience that gets passed on to the visitors, I think. What really interests me about the Exploratorium is that everyone is so interested in everything and how things work. And this incredible curiosity. And that's sort of how the exhibits get developed. And rather than sort of thinking, well, I'm going to teach something I already know, the best exhibits come when you start trying to teach something you don't already know. And I always knew that there's a curie point in iron, and that when the iron got hot enough, the magnetism went away, but I've never seen it. I've never done an experiment with it. And it was really amazing to see it happen, and to see the thing hang on to the bitter end until it got really red hot, until it got to the curie point, and then finally just flip off. And just had never seen that before, and seeing it somehow helps one figure out how to do the exhibit.
Well, this is lower, but other than that, I don't know.
Yeah, I guess that's about all.
Okay, what happens here then? It sounds better. This one. What's the difference?
General
I
physics
don't know. There
ruined
is
pendulums
something
for
about
me.
it, though. You see an awful lot of springy hardware stuff. It does. It's like what Peter Stevens said when he came over. It looked like somebody went nuts in a hardware store.
Okay, but I think it's pretty.
Well, it's nice
Yeah.
in a way, but it also may make it hard to see what it is you're trying to show.
I'm going to make these.
Maybe having the price tags, you know, and everything.
That's part of it.
I'm going to make these bearing.
All it does is they go together
I
when
know.
they're opposite. They go together when they're the same, and they,
Yeah.
they exchange
That's
when they're.
great.
And that's all.
That's great.
But that's all it does.
Yeah, that's quite a lot. You set out all these wonderful props with some system to them, some structure, like a piece of music, and then the public of all ages, all sizes, all levels of education use it in their own particular way.
Very good.
Steel, so that the way they vibrate, that it's going to be squashed down and then come up again like that. That's why the shape.
What you see depends on the frame of reference you look at it with. And what happens is your eye wants the simplest explanation. It wants the simplest frame of reference. So what you do is you...
All sorts of students and teachers use the Exploratorium on a regular basis, like Mark St. John, who brings his undergraduate physics class.
Every exhibit here is like a demonstration exhibit in a college classroom honed to perfection. When we come here, it's like a smorgasbord of experience. And they can feel things and touch things and play with things, so that when I do the mathematics on the board, they have a sense of the phenomenon and almost in their bodies. A lot of physics is working with equations and using formal logic. And of course, the real science involved often involves play and discovery and kind of what you learn before you know what you're studying. It's that kind of sense of really making it up for yourself. And that's the part of physics we almost never teach, which real physicists do all the time.
I'm not sure I save any energy turning all this stuff around, but yeah. The last rack. Oh, this is a wonderful thing that Rick made. It's a disc from a plow. You could just put that out for people to beat on, and that would be kind of. It was part of the a variation of the Bells exhibit. That would be kind of neat. If you tap it in various ways, it goes into various modes, and you hear just sometimes a low frequency just edge on, and other times you hear the higher frequencies. It's a really nice thing. Somebody's tightened this. It has wonderful mercury vapor tubes that light up blue in the bottom, and the jugs in the top light up, you know, a nice bright color. And it's all 1930-ish design, and I think it should be out as an exhibit, and maybe it will be when the electricity exhibits go. But it was at a junk shop for 15 bucks, and I figured, well, you don't get those things every day. If it ever gets used, it gets used.
It's beautiful. Look at that, and it doesn't. A little bit the tip.
Yeah.
What's interesting is.
Oh, you just touch it. You're not pulling it over.
No. These are the magnets. I think are used for the exhibit because it's really powerful. They're old radar magnets.
To keep its doors open, the museum needs 100 employees, a machine shop, art department, biology lab, a great deal of ingenuity, and $2 million a year. But what it needs most right now is a 10-amp switch.
That's... Here they are. Should be a big one. We had a big one in here somewhere. Oh, what I want to do is switch about 10 amps.
Okay. That's a marginal socket. That's 11 pins. We don't have those. They're very expensive.
All right.
Like all public institutions, the Exploratorium is scrambling for funds. One new strategy is to rent out the museum for private parties. A group of bankers want to book the Exploratorium for a black tie affair, but they also want the explainers dressed up in black pants and white shirts.
I think it's perfectly legitimate to tell the explainers that it's a fancy event, and if you're working that night, come dressed up. But let them decide what dressed up is.
There are so many places where there are dress codes. When I was a service station attendant, you had this little outfit you had to wear.
This isn't one of those places.
And when I was at Macy's as a janitor, I couldn't wear tennis shoes. No one ever saw me. I couldn't wear tennis shoes. They'd react to that like...
We were well ahead. I would say, fine.
But we never compromised. So we've been broke many times.
Not this broke.
We all took a voluntary pay cut this year. But that didn't mean we started doing things differently just because we were in financial difficulty. This place has been in financial difficulty ever since it started.
Well, Bob, I take a different tack on that. I don't think it's a question of the severity of our debt. I think it's a question of whatever term you use, what's right.
We should do what we do that we think is honest, and if people like it, fine. If they don't, then...
But that's not very businesslike.
But we're not, this is not a business.
We are a business.
We are not.
We are
As important as it is to raise money for this place to keep it alive, we are not a business. The purpose of this place is not to make money. The purpose of this place is to build a very good science education museum, and those are two very different things.
Bob,
well, you won't do it without money.
I just can't take it that seriously.
Yeah,
this is a fundraising strategy.
It's just like building an exhibit. It's all those little decisions that you make as you go along the way that you end up with a good exhibit. And this place is good as a whole, I think, because we pay attention to all these things. And I think all these little decisions are important.
Just think how much nicer it would have been if somebody had said to the explainers, we want you to look nice and now figure out how to do it, and they could have agreed on it themselves. I think that would have been a very nice way to do it, and I think it's the way we should do it still.
Yeah, but I agree with you that
well, then let's do it. I mean, I think let's do it the nicer way.
Yes, but that's the nicer way for the explainers and for us. But is it the nicer way for an important client? And do we care about that? And you're saying, no, we don't care about that.
I don't care about that. I want the tradition that we control our own employees, that the people who come in here may ask us to do things. We can say whether we want to do them or not, and we make the decisions about what happens at this museum. We agreed that they can have the wood and so on. And I think it is our right, and that what we should do each time is we make our own decisions, and just because somebody's paying for it, we don't do things which we don't think are the right things to do.
Even if it jeopardizes funds?
Even if it jeopardizes funds. Christ, we've jeopardized a lot of funds because we're so funny.
The director of the Exploratorium is an idealist, but he has also been a cattle rancher, and ranchers are pragmatists.
I learned about getting things stuck and unstuck, how to make things oneself. Mostly one learned how to improvise, because when you're in a ranch that's 80 miles away from a veterinary and hardware store, you really try and scrounge and find things and put them together. So it's just one continual job of trying to undo the property of nature to increase entropy and disorder.
It was not entirely by choice that Frank Oppenheimer left physics in 1949 to raise cattle. Back in 1936, as the Depression wore on, the U.S. government took note that Frank had joined the Communist Party. 4 years later, he left the party. During World War II, Frank and his brother, J. Robert Oppenheimer, worked on the atomic bomb project. But after the war, the House Committee on Un-American Activities summoned Frank and his wife Jackie to testify about their pre-war political activities. They spoke freely about themselves, but refused to implicate others. As a result, Frank was fired from the University of Minnesota. Job offers from other universities were mysteriously withdrawn. Unable to teach science anywhere in the United States, he spent 10 years ranching in Colorado. Frank Oppenheimer had been blacklisted.
When Jackie and I went to the House Un-American Activities Committee, they asked me about our past, and we told them all about that, but they asked us about a lot of other people, long lists of people, and we refused to talk about them. And even though that was in principle contemptuous, they didn't do anything about it. But the FBI kept coming around with the lists of these same people, time after time after time, and
even after you were
when we were up in the mountains, and asking us. And they also talked to other people and tried to make them suspicious of us. They asked whether we were doing any experiments, you know, the mad scientists doing terrible things, or whether we had any radios communicating with the enemy. But I didn't try to do any physics.
Did you miss physics when you were?
Yes, I missed it.
But in 1959, Sputnik helped change national priorities, even in Pagosa Springs, Colorado, where Dr. Frank Oppenheimer was asked to teach high school science. He became intrigued with his students' appetite for hands-on experiments and rekindled his own enthusiasm for teaching. This led to work in science education at the University of Colorado and a study of science museums in Europe. In 1968, Frank and Jackie Oppenheimer landed in San Francisco with the dream of opening their own museum. Within a year, they had a small staff and $1 a year lease on the long empty Palace of Fine Arts.
When I started the Exploratorium, almost everything that I owned or that I had ever done was involved in building the place. The teaching, the curriculum, things that I'd done, but even the ranching. And instead of telling anybody about that we were opening, we just opened the doors and watched what happened. And it's a beautiful park, and it was in summertime in the end of August, and people started coming in, and all of a sudden we realized, wow, we have a museum that's open, that's going. But the way it turned out to be is very different from the image I had it with a lot of little boxes like other museums.
Okay, here you have is what the eye looks like. First of all, what I'm going to do is cut off all the muscle and fat.
Did you find a dead cow to do it?
You can even pull that fat more apart from the eyeball itself. That's it.
This thing got 2 eyes?
There you go. This is a cow's eye.
See what's inside it.
Here's this picture of the muscles. Now what I'm going to do is cut along right here.
Yeah.
Okay, what you'll see is a jelly-like substance called the vitreous humor. Okay, can you see it? Okay, it's like a clear jelly substance, and it's what gives your eye its shape and its form, and like holds it in place. Okay, there, you can see it? Okay, see how it's like jelly?
I wish I did.
Its shape that makes it hard.
Yeah.
Okay, I'll take that out.
The lens maybe. That feels like water. I know. It's cold too.
Okay, here you can see like the lens inside. Everybody see that?
What's that round thing?
Okay, And so I'll take the lens out now so you can see.
That's a marble, it looks like.
Yeah, it does. It's a lens, though. This is the lens of your eye. And I'll hold this up and you can look through it. And you'll see that when you look through it, like I'm upside down. Can you see that? Everything's upside down.
How does that do that? That's really what happens when you see something.
Do you know, wait a minute, there's little rusty on the cow. This is really tough because like they're closer to the ground, they need more protection.
Sticky.
Is it sticky? Cow's eye.
Let's go now. I found out something very interesting.
You did? Where'd you find it out? Did you enjoy it? Thank you.
No, I see both at once, actually. I see two heads.
Don't freak back in.
You gotta go. Go with an improvement.
Ha ha ha. That looks gross. Stop.
Ah! We gotta go.
Watch this, we'll phase out.
Put it slow.
I know, slow is bad, but
Frank's pendulums work smoothly now, transferring energy from one to another and back again. But this is a subtle and complex machine with two natural frequencies. The transfer of energy is caused by a kind of tug-of-war between the frequencies. Two modes. In the first and most obvious, the pendulums will simply swing back and forth together in tandem. In the second mode, the pendulums will swing precisely opposite one another at a slightly faster tempo. Two completely different modes of behavior, separated only by a tiny shift in frequency. Frank's proof that these alone are the system's two natural frequencies lies in his ability to excite these modes, and only these modes, by simply pushing either pendulum at just the right frequency. Simple and elegant for a physicist. But now, how to intrigue visitors as well?
Mine doesn't sound like E at all to me.
No, it does to me.
Huh. That one's not as good. Ooh, now that's an ooh, and with the gravelly one it's an O.
How does this shape here correlate to the shape that produces the vowels?
Okay, this shape corresponds to the area of your vocal tract at any point. At any point along this length, this would be the soft palate where there's that constriction. You have the soft palate hanging down the back of your mouth. This would be the front of the mouth cavity itself, and here would be the teeth and the lips.
Now what sound is this again?
This one is for ooh, where your lips are real closed down on the front, so it's very constricted.
Yeah, that's what any resonant chamber is. I mean, a musical instrument will do the same thing. If you want to play a note of a flute or something, you're changing the resonance in the cavity of the flute, and this little cavity here accentuates some parts of the sound, and this one here accentuates other parts, and then together they make a certain vowel sound. I mean, this doesn't look like a vocal cords, but it's vibrating to act like a vocal cords. And the bellows aren't going to look like lungs, but they're really going to act like it by forcing the air through. And you can use these here, or you can use them on the adjustable one also. So
What would two of these sound like together?
Would you like
that? Yeah, I would. It just occurred to me as you said that.
The speed may not be quite right for anything. And that just goes every time. It gives it a little push, and that two go together, so that together they're a resonant system, even though I'm only driving one of them. And if I let that go, they'll just stay like that.
Yeah, you can really feel it sticking on. So you can, yeah, it's quite strong. Okay, and it's obviously not there when you turn it on and make it hot.
With the Curie point's mechanical problems in hand, thoughts turn toward letting visitors actually feel the magnetism disappear at the critical point.
Yeah, I think that is.
But to do that, you're going to have a stick or a pole or something.
That's right. You don't want people touching it anyway.
Right.
Why do you have to have this happen automatically? Why can't the visitor
Because you
turn
can't
it on
let it
and
stay
off?
hot forever, I guess.
No, I thought it would be
on
fun.
one of those switches where you
I
can
like
turn
to have things moving when people walk up.
They decide that a mercury switch might be rigged to turn the heating element on and off automatically.
So the trick's going to be whether you can get enough of a tip with that stainless steel so it'll turn this on and off. And hopefully it won't oscillate back and forth, so it does kind of like this. Now to try it. There we go. And it starts to heat up.
Oh, hang on.
You got a contact?
Yeah. No, it's
You just welded the stainless steel together.
I just pry it apart again. Why don't you pull the plug on the relay?
Happy life for relays in here. No. Okay. That's a magnetized screwdriver.
Kind of hot.
Yeah.
There you go. All right.
It does work.
It's pretty weird, isn't it?
I love
it's not exactly elegant. It looks kind of like a cow jumping off a rock, you know?
Somehow I had this picture of a pendulum kind of swinging nicely away.
We have one exhibit that's a 19th century projector, and it has a little kerosene lamp to light it up. One day the kerosene caught on fire, and there were great flames inside this glass showcase, and all the public visitors stood around and looked at it, waiting to see what was going to happen, assuming it was just another exhibit, just a normal thing happening in the Exploratorium.
This sand is actually iron. It's really metal. Even though it's in such small particles, it's like sand. See what it feels like? See, and when you take the metal sand and put it near a magnet, it affects the sand. You see?
You can also see how the magnetic field goes through you, too.
If you go to the beach and bring a magnet, you can take your own sand off it and bring it home and play with it just like this.
Oh, he's growing hair! We're cutting his hair. When we cut his hair back on, great job.
Oh là là. Qu'est-ce que tu penses? And it doesn't feel like anything you've ever felt before, but it's a common straight pin. I mean, it's not very complicated also. It's a perforated piece of metal. And depending on how long a pin you use, it depends on how high you should have the glass. 170,000 straight pins.
Why do they have glass on the table?
Not quite there. What the hell? That's too much of a pull. Let's try it once more now. Takes a while to build up that resonance. Hey, great.
Very nice.
That's nice.
If you just damp it, then it takes a longer time to cool down to the point where the magnetic attraction is great enough to...
That's neat. That's enough.
I like the switch because it's more straightforward.
It is something that's in your household as a thermostat.
And also, there's no reason why you couldn't, let people hold this away from it and actually turn the metal off for a longer
Yeah, we were thinking maybe having some kind of pole or something you could push away a little.
Building exhibits is teaching. We're always finding something that we made an exhibit on that we don't quite understand, and then try to explain it to each other and figure it out. And it's amazing how the process of teaching helps you understand.
Feel it. If you put a little magnet there and it goes da-da-da-da-da-da, and you can feel
It's like the demagnetizer exhibit.
The magnetism comes from bound electrons on the iron. How are they different, though? Because the conduction ones are free. They're the outer electrons that are free to go from one to the other, one atom to the other, moving as they want. So.
And the magnetic electrons?
The magnetic are still bound to the atom.
Inner shells?
Inner shells.
So what you got is the motors going around and around like that, and the wheels turn right here. And what it does, it changes the direction of the force. How about that? You want to go look at the big one? Go look at the big one. See? There's a gear, just like in the other one. See it right there? Yeah. Okay, that's the same gear as the little one. You stop it here, you stop one.
Like the hammer keeps on going.
That's because they're floating on it. See this right here?
You'll control it. You'll control the speed.
And then it slows you down.
Any part of your body that you can extend will slow you down. Now, why is that? Okay, when she spins here with her leg out, as she keeps her leg out, right? Okay, her leg has to travel all the way around this whole distance here that I'm walking. Okay? But when she puts her leg in, she doesn't need as much energy to go the same distance. And the extra energy is converted into speed, and she goes faster. And it's really interesting because she's using the same amount of energy all the time. You stick your leg out and spin, and then bring it in. The difference between your speeds isn't very great. But if you stick your entire body on the outside, and I'm going very slow, if I move my body to the center, it's proportionately so different that I get incredible speed happening. So the greater mass you start with on the outside, the greater the proportion is to your speed. So if I go very fast on the outside, when I come in, it'll go so fast it'll throw me off. Whoa. And now, of course, it's time to fall down on my face.
The longer a pendulum goes, slower it swings.
The coupled pendulums, curie point and vocal vowels are nearing completion. Now for the finishing touches.
Temperature of the steel plate there too, because when it gets too hot, it's not attractive anymore. It just falls apart.
When the atoms go back to normal, even better, they get less active, and they become magnetized.
What it is basically then is
when you heat up things, you increase the kinetic.
The electrons start moving around erratically, and it screws up the north-south line then of the number.
Steve, you want to pull this and see what it does? When you pull it over there for some reason, now let it go back and see what happens.
Oh. So watch when it gets real hot, push it.
I had talked about on the graphics about
the stainless steel.
The Curie Point exhibit works, cooling and heating, attaching and detaching fairly well.
It doesn't seem to be doing it now.
But not quite well enough.
We're going to be here all night. Is that it'll break through and we don't have anything. Okay? In other words, be patient. When we get the other stainless steel, we'll goof around some more. It's not perfect yet.
Nobody will admit to putting them on, but I guess
they just appear.
Wayne drew them.
Why don't we take and retype this? Changing the order. Yeah. And then I'll stat it out. Yeah. We'll put it out. We'll put it on the floor and just see
what people do.
See if they come.
But
in.
It would be easy to have a cover on this.
Where are you going to put it?
Down near the other resonance exhibits, but I don't know where yet. I should. That's good.
Right over that thing there?
This is just temporary until tomorrow the new power supply will come.
What we're going to do is to put some energy into this weight here, this pole, by letting it go, and it's going to start swinging. But since this pole is connected to the pole that's hanging, we're going to transfer the energy into the other pole.
Okay.
In the museum, there are many, many examples of the various concepts. For resonance, for example, if you go from one end of the museum to another, you keep running on to different aspects of resonance so that people develop these concepts on their own rather than having somebody give the dictionary definition.
Oh, it's magnetized.
No, it's not.
No.
The thing moves up there.
Oh.
It moves the thing up there, and then that one would shut it down.
And then this one stops and that one keeps on going.
Then it moves that one.
And then
that one stops, that one goes. Yeah.
Oh.
That's neat.
Listen to the different sounds. Listen. This one's very mellow.
When you push it in and the little thing moves, it makes a noise. Oh, and then it hits that piece of wood. Yeah. And then it goes up there and makes a little thing.
As your mouth does when your vocal cords are going through it, right? So then guess what sound that is?
Just keep pushing on it. Keep doing like that, yeah. And we do it like this, too.
seems to be a success. Popular, at least.
The basis for social change as well as technical change, I think, is understanding how nature behaves and how people behave. And if one can promote that, if one can create confidence in that, then there's some chance that we won't blow each other up and that we can have a decent society. So the Exploratorium really was founded on a kind of optimism, and with the momentum of the Exploratorium, I'm not going to stop. I'm going to maintain that optimism.